Hi guys, welcome to my YouTube channel. I hope you are okay. Me too, I am fine. Thank you for being part of my YouTube channel, and I greatly welcome you and appreciate you. And so together we thank God for yet another opportunity to learn. So let's continue with our lesson from where we left. So today guys, we are looking at the rules of differentiation, and in looking in the rules of differentiation, we are going to solve several problems. For example, we continue with the chain rule and also the product rule. So we shall be looking at this rule and this rule. So guys, let's do these problems that we have here. And so we look at Roman 1 and see what we can get. The question reads, find dy dx given that y equals to that and y also equal to that. So let's begin with the first one, where we are going to use the product rule. So this is how we do it. Before we do that, we can write the product rule. The product rule is supposed to be like this: dy all over dx is equals to u dv dx plus v du dx. You come to learn that it is product rule when you look at the function and see the product of two functions that are not similar. For example, x cubed multiplied by sine squared 3x. That tells you that these ones are different. And so we are supposed to multiply them. By so doing, we use what we call the product rule. And the product rule is as shown. So we say, let x cubed, we can say x cubed be equal to u. And so du dx, we can say du dx is supposed to give us, now we are starting this side, it will give us 3x squared. That is our du. We continue. Then let sine squared, that is sine squared 3x be equal to v. So that's what now we are going to differentiate. Looking at sine squared 3x, we find that we need to use the chain rule here. And so we can develop our question here whereby we are going to use u and v, of which that u is not this u or this v. So we come and write, for example, if you are given a question like this, y equals to sine squared 3x, like that, you can actually say, you can give u, you say u is equals to 3x, like that. That is sine 3x, like that. So that du dx is equals to cos 3x x, and then here we are going to have 3 there, because yet it is going to have still another chain rule because of this 3. So now we put it like that for the differentiation of du dx, like that. But then we have dy du. Dy, because u we said is sine 3x, so dy du, this one is going to be 2 sine 3x, like that. So if you multiply du and you multiply by this, that is du over dx multiplied by dy du. So this one gives you dy dx, and that's what we are looking at. So this one is a bit different in that we may not be able, we don't want to copy that because our u here is not similar to this u. But finally our differentiation dy dx, it's like our here dv dx. So dv dx is going to be equal to, now we write du dx for this one is 3 cos 3x, you multiply by dy du, that is du dx. Du dx is that, dy du is supposed to be 2 sine 3x, like that. And so from there we use our product rule now. So we shall say dy dx, this one is equal to u, which is x cubed, and then dv dx, this one is supposed to be, you can multiply 3 multiplied by 2, then you can put a 6 here. Yes, 3 times 2, then we can put cos 3x sine 3x plus, now we put v, this is sine squared 3x, like that, that is our v, and then we put our du, du is that, so this is 3x squared, and we can put it like that, so that now we can rearrange our question to read like this: dy all over dx will give us 6x cubed cos 3x sine 3x plus, we write 3x squared sine squared 3x. We can simplify further because we know that 2 cos x sine x is equals to sine 2x from trigonometry. So we don't have to simplify, but we can simplify further if need be. So dy all over dx can be written as, can check this and that. So for this one we don't have a 2, or we can put this 2 here. So you have 6 all over 2 x cubed, and then this one is double while this one is single. So this one will have to multiply by 2 this one. So we'll have sine 6x, just as we see here. This one is double, this one is single. So if this one is 2x, this is x. If this is 3x, this is going to be 6x, like that. Plus 3x squared sine 3x. Here we have a squared. So this is what we get. So actually this one can finally be, you can have dy dx is equals to, this is 3x cubed sine 6x plus now 3x squared sine squared 3x. So this is going to be our final solution now, guys. And so guys, we continue. So guys, this is how I can do that question. And the question is as shown, it's here. This is the question we were doing. This is now the question we have done, and we get this answer. So guys, we now come to do this last question we have here, which is now using the chain rule. Here is our question here. It's actually this one. So let's attempt and see what we get. Now we come to our question here, Roman 2. So this one, we approach it this way. It's actually a chain rule question, and we can write the chain rule first. So that's how, this is how we write the chain rule. dy all over dx, this one is equal to dy du multiplied by du dx. That is the chain rule. So coming to our question, this is how we approach it. Now we shall say y is equals to, we have e like that. Then we can say u, where u is equals to sine 2x, like that. Then we say we will get du all over dx, that is dx, this will be equal to 2 cos 2x. Somebody might ask where the 2 has come from. Actually, for this one, we still use chain rule once again, whereby for the chain rule this is how we understand it. First of all, you differentiate from the outside. That is sine, whatever it is inside there. You get cos, whatever is inside there, which is cos 2x. Then you go to the inside. You differentiate again. 2x, you get 2. So that is actually the chain rule principle. Then we come and say dy du from this, you'll get e raised to u, because from our rules of differentiation, or from the differentiation of e raised to x is equal to e raised to x. It's like that. And so Using the chain rule now, dy dx is going to be dy du is e raised to u. Du dx is 2 cos 2x. So we can now replace for u. So you have dy dx will be e raised to u, which u is supposed to be sine 2x. And then you can put this 2 here. And then you put cos 2x. In other words, I can write it even better like this. Dy dx is supposed to give us 2 e raised to sine 2x multiplied by cos 2x. And so this is the value we are looking for. And so guys, the question we are looking for is this. The solution for this is supposed to be done like this, whereby we have this is our question, and we do it like that until we come to this solution. Guys, I hope you understand, and we come to the end of our lesson today. Please guys, we meet next time. Thank you.